So we have our exercises here. So we're going to answer this exercises number 2. Write a description of a 4-bit up counter named counter 4. The counter increments on the positive clock edge only if it is active low enable is asserted. If its count by 2 input is asserted or active high, the counter increments by 2. Otherwise, it increments by 1. If the counter overflows, it continues to count starting from 000 from 000. Then the counter has an active low asynchronous reset or end reset. So, on the control table. So, as what mentioned here, so sa positive edge ra si Zas, if ang clock na to is at positive edge, then it increments or R in E is at active low. Then i-check pod na to is if our count by 2 is at active high, then it will increment by 2. Otherwise, it increments by 1. So, if the counters overflow, so mo balik siya count to 0. Then i-check pod na to if RN reset is at active low. Then if it is an active low, so the counter will reset to 0. So here's the table. If n reset is 0, so R enable and count by 2 is don't care, then the output is 0. Then same as here, then the reset, so the reset is 1. But RNE is equals to 1. It should be active low so that our counter will increment by 2 or by 1. So our output is still 0. Then here, so our condition meet, so R and reset is equals to 1, then in A is active low, then we'll check our count by 2 if it is true. Then if it is true, then we'll increment it by 2. Then if it is false, then we will increment it by 1. So here's my code. So here I have 4 inputs: the clock, the in E, the count by 2, and the in reset. Then the output reg 30 out, always at pulse edge clock, pulse edge clock. Then here's our condition: if n reset or not n reset, it means that it is 0. Then if our n reset is equals to 0, then our output is 0. Else, so if our n reset is equals to 1, then we will check R enable if it is 1. So here, if not in A or R enable is equals to 0, so it is an active low, then we should also check the value of our count by 2. So if count by 2 is true, then we'll perform the increment by 2. So out is less than or equals to, then out plus increment it by 2, but it is represented it in binary form, so 4B0010. Then else, if our count by 2 is false, so we'll increment it by 1, so out less than or equal to out plus 4B001. Then else, if our enable is at 1, then or active high, our output is still 000. Then here's my stimulus generator, then the test bench. Then we'll try to run it. So here's our test bench. So as you can see, if our count by 2 is 0, then it will increment by 1. So from 0 to F, which means 0 to 15. Then iguman na 15, sumabalik na to sa count 0. Then if our count by 2 is 1 here, so our output start incrementing by 2. So from 0 to E. So 0 2 4 6 8, A for 10, C for 12, E for 14, then it will go back counting, start from 0, 10, and so on. So that's all for 4-bit counter.